Assalamualaikum everyone. I am Dr. Madiha and today I will tell you about characteristics of polymer. So first of all, characteristics of polymer having the low specific gravity and high specific strength, has a thermal and the electrical insulation, corrosion and weather resistance, ease in design and manufacturing of complicated structures, outstanding aesthetic appeal due to the ease in addition of a permanent colors. Next, mass production with a low energy intensive manufacturing techniques, ease in printability and adhesion, ease in handling and the cleanliness, offering tremendous scope of physical and the chemical modification to meet industrial and the consumer requirements. Application for the polymers basically industrials, building and construction, electrical, electronics, engineering, furniture, medical, packaging, textile and transport. In agricultural, its importance and characteristics: water conservation and management, reservoirs and irrigation lining, water tanks, and next is a pipe for drip and sprinkler irrigation, greenhouse covers, production collection and the packaging, fertilizers, livestock and the machinery and tools, and application of a polymers in high technology polymers for advanced structures for high performance plastic fibers and network engineering, polymer blends and the fiber reinforcement materials, polymers for information technology, electro and photoconductivity polymers, information polymers for non-linear optics, and pyroelectronic polymers, organic semiconductors, and also have the polymers for the enhanced oil recovery. Polymers for biosystem control release and the target drug carriers, biosensors, biomaterial, biodegradable polymers. Whereas application of polymers have the permitted all the aspect of our life, health, medicine, clothing, transportation, rather electronics, energy, employment, and the trades. What is the 10 fact and the plastic everyone should know? Plastic are one of the most resourceable, efficient, and the versatile materials available to society. Plastics make a significant contribution to the vital goals of sustainable development, social progress, and plastic provide affordable products, spring more power across the highest standard of living, and also environmental protection and help to resources fossil fuels and the energy. Plastic consume only a teeny fraction, just 4% of the world oil. Plastic produces in use save oil. Plastics are too valuable to waste even at the end of the life after serving a useful purpose. Plastic can either be recycled or used as an alternative fuel. Renewable energies rely on the plastic solar panel, wind turbines. Over 1 billion people in the world lack access to safe water. Similarly, no one material can compete with the plastics when it comes to meeting technology demands while preserving resources. Plastics are the champions of the preservation, and also without plastic packaging, the weight of the packaging would increase fourfold production cost and energy consumption. Plastic make our life safer. Airbags, seat belts, baby seats, bike helmets, medical devices, and are just some examples. The use of a plastic in automobiles, in small cars, and aerospace, and also examples of the exploited machines and percentage achieved for the theoretically maximum values: polypropylene, polyamide, glass, steel, and aluminum. Monomers basically simple molecules that are covalently bonded, and also by which the monomers are chemically combined with the long chain. So you can see here when acetylene heated and pressurized, it catalyzes to form the subunit in the polymer chain, which is called a mer. And n degree of polymerization number of such units or the mers in the polymer molecular chain. Average dp for the p is equal to 3500. Chain polymerization initiation, propagation, and termination completed with the three steps, having the unpaired electron, free electron, which covalently bonded to an unpaired electron of another molecule, and similarly benzoyl peroxide free radicals, and termination. He is the vinyl and the vinylene polymers, and he is the vinylidene polymer. Example: step polymerization, hexamethylene diamine adipic acid. You can see here nylon. Homopolymers, polymers chain made up of single repeat units. Copolymers, basically random copolymers and alternate copolymers. Block copolymers, graph polymers. Here's a classification. Common names. Some names are derived from the place of origin, and just like in diamond, and the source and the base. And similarly, historical perspective of the this one, here is the epoxy resin, polyester, span, fibers, HD, Fe, Pi, and something else. Plastics are the two types: thermoplastics and the thermosetting plastic. High tonnage or the commodity plastics, general purpose engineering plastics, and the super engineering plastics. Plastics, basically, high tonnage or community plastics examples and the enduring plastics examples are given below. Here is the specificity in enduring plastics: polysulfones, polyacrylate, and polyetherethane ketone, and polyamide, polypropylene. Here is enduring specially polymers. Here is the polyamide, parabenzobis diamine, and similarly here is the typical properties of the commodity resins, which are used just like LDPE, LLDPE, HDPE, NPS, HIPS, PVC, PVR, PMMA, and HIPMMA. They have a different type of density and energy and temperature and HTT. The symbols are density, glass transition temperature, melting point, heat, and tensile module, maximum strain at break, and the non-applicable. There is the typical properties of enduring resins with the PA, PA66, PETG, PT, PBT, and the PC, POM, POMGF, PPE, and the PPEGF. Here is the all properties of our typical specified resins. Here is a especially polymer and the composites, high performance formal hydrophilic polymers, polymers with the electronics and the photonic properties, high temperature and the fire resistance polymer, liquid crystal polymers, ionic polymers, advanced elastomers, specificity, blend, and advanced composite in the biopolymer. In the composite is the bird market share by the resins. Type of a resins and the market share. Here is the typical properties of a commodity resins, which is commodity enduring and the specificity, and the competing enduring and the specifically resins mostly help with the older material, and they have specified their applications. We have the thermoplastics, which has the following characteristics: soften when heated and harden when cooled, and irrespective of the number of a time the process is achieved. They flow with the pressure and the heat. No chemical changes take place in them upon heating. Temperature to use in limited TG can be processed a number of times. Responsibility and the composers and the environmental stability is enhanced with the crystallinity, low density, low energy requirement for the manufacturing, and the low product processing cost. So enduring plastic have the following properties: high tensile strength, high module, high impact strength, low creep under low high TG, and the high service temperature. There is a thermosetting polymer. These reasons are chemically reactive substance which undergo hardening to produce the insoluble and infusible products. And the polyester, epoxides, and the polymers are widely used as a mattress material in FRP. They have the simple characteristics. The thermosetting polymers are generally producing the reaction of the resin consisting of a linear long chain molecule with the harder, and similarly the one heated, the heat irreversible to form the intermolecular covalent bond, and some dots often or flow upon second heated even have the application of pressure, can't be reprocessed, and use temperature limit is higher than the under plastic and is governed by the degradation temperature, generally dimensionally more stable than the thermoplastic, and these reasons have combined products of the high modules, creep resistance and hardens, and dense cross-linking generally leads to brittle material that are the subjected to failure by the growth of internal flaws and the cracks propagation. They are amorphous, and similarly cross-linked densities of a cross-linked resins are approximately uniform, and prior to cross-linking thermosetting resins may be low viscous liquids or they may be glassy solids, or initial formation of a cross-linked insoluble network which occur at a point called as a gelation, and cross-linking also gelatation, and the resin becomes soft and weak gel. So here's the specific gravities and the metrics of the composite that serves the transfer load, and also it protects the fibers from the environment, and the properties of a composite that are significantly affected by the properties of a matrix, which are the bond, temperature, longitudinal compression, transfer strength, toughness, fatigue, trial, and the creep resistance. And then here is the polymeric thermostatic material, which is come closer to ideal material, at least for the application up to 200 degrees centigrade. Here is a classification of a thermoplastic polymers, and here is a thermoplastic low polymer densities, Examples, and there is a hydrophilic polymer, natural polymer, carbohydrate or proteins, and there is a semi-synthetic proteins and the synthetic property, physical properties, a state of a polymer, glassy state, rubbery state, and a viscous state. Here is the motion in the amorphous state, crystallines in the polymer, basically regularity in polymer chain, flexibility and packaging. And here is the second order transition, characteristic of a TG, which can be rendered group on the restriction on the torsion about alpha bond in the backbone chain, and that is the backbone chain becomes the less flexible. And we heard some calculation of their TG, and the plasticized effect on the temperature which decreases by the TG, and the polymer is a less torsion. There is the glass rubber transition, glass is a transition, so the second order reaction, and kinetics is upon the rate of a cooling, and the thermodynamic transition in the free volume variations. And here is the effect of some mass of a polymers with the effect in the flexibility, geometry, and the molecular symmetry tend to the lower TG. So intermolecular force is the presence of a polar group with the hydrogen bonding to form the tend to raise the TG, and similarly the exit of a cross-linking also increases. There is a melting of a polymers, which can happen. The mole TM is directly proportional to the TX. For a given mass or a volume of a polymer shorten the chain, more random it will be upon. So there is some factors which encourage the crystallinity is the polymer random polymerization, bulky side group, chain branching, lack of a stereo regularity, and the certain geometrical isomers. There is a stereoisomerism in the thermoplastic, which is basically example is 1,3-butadiene, and here is the crystallization in the polymers, which is sprinkled bipolar model and a folded chain model. And in these two characteristics of a crystalline and amorphous polymer, which is basically is the main excellent chemical resistance and dimensional stability, and the sharp melting point, and the warpage resistance, and also nylon example ABS pyroline. And here is the molecular architecture, increasing backbone stiffness, increasing the decomposition temperature, and also the ABCD incorporation of a group. Here is a group linkage. Here is the properties date of the some fluoropolymer by the specific gravity, elongation, and the continuity temperature. There is a typical bond length and the dissociation energies for each selected primary bond. There is the replacing CH3 group by the phenyl group. As you can see, here is the repeating unit of a PDMS, and here is the some different type of brass, mild, polyamide, polyacrylate, polyamide, and examples. And this shows the energy requirement to make the various engineering materials. And here is the bottle glass, low density, polymer, steel, aluminum, and the brass. Here is the units and the different type of properties, which is identical with the polyethylene carbonate, and the different type of table which gives the examples. These all are the examples which can be you can aid it with the property data for some of our polysulfones and the thermoplastic polyamine. Then is the characteristic of a simple rubber. Rubber, which is basically elastically means a large deformability and with the almost complete reversibility rubber. And rubbers are basically characterized by the high elongation of the break rubber, thus have all able to used in the extension owing to small atomic masses of atom and insufficient chain packaging. Rubber dissolve the slow in the appropriate solvent. Rubbers are viscoelastic, and the rubbers show the joule effect at the moderate strength. And also with all these propagations, there is the process of vulcanization, which is the chemical process by which unsaturated elastomers polymers joins together. And these all are the example of these sulfonization elastomers, and rubber example, cross-linking, and the thermoplastic elastomer TPE, and the butadiene based elastomers. They contain the rigid glassy polystyrene and the soft PB segments. And here are some example of NBR, polyisoprene PB, and the PB and SPR. Here is the natural rubber and the vulcanization process. They are the elastomers which can be used for the polymer. And in our last one is the properties of a different type of a rubber and the polydiaphragmy and vulcanization process. Polymer additives are basically the fillers, plasticizers, stabilizers, flame retardants, and the colorants. Fillers are basically wood, floor, and silica oxide. Plasticizers to improve the flexibility. Stabilizer is basically tertiary disulfide, and the flame retardant halide, and the colorant. Similarly, the end length and the end distance and the radius or the gyration. Contour length, which is basically is directly proportional to the n, which is the number of segment, and distance, the statistical method which is used to calculate the end-to-end distance of polymer, applying random flight model where it is assumed that all the segment lengths are equal. Root means here of n, each distance is given by the n ones here. So here is some textbook which can be also elaborated for my material. which is basically WL Calcier, and the William F. Simmel Polymer Science and Technology JR by the Revon Material Science and Engineering, and also the JSNN application of the plastic. Thank you so much if you understand these topics.